The domain of G, if you look at the graph, you can see that G basically goes from -4 all the way to 5. So we know we're going to start here at -4 with a bracket. And then do we have any breaks in the graph? Well, there is a break in the graph here, but there is an output for -4, so we're going to use that. And then output just to the right of -4. We get to -1, there's still an output. Okay, there's still an output at 2, and there's no output though at 4. So the domain of this function is from -4, all real numbers from -4 to 4, including -4 but not including 4, and then all the real numbers from 4 to 5, including 5, but again not including 4. So that's the answer for the domain of G, number 64. The range of G, it looks like it starts down there at -2, and it goes up, and it keeps going, and all y values are accounted for except at 3. I see that. Tried to be a little bit sneaky there. And then from 3 all the way to, what is that? From 3 all the way to, oh, you know what? They were a little bit sneakier than I was. 3 is included. In fact, 3 is an output when x is 0. So there are no breaks in the range, and so therefore the range is from -2 all the way to 4. -2 all the way to 4, including -2 and including 4. F of -1 is -1. Okay. Let's see, what else do we have here? Number 67. Is f continuous at C? Is f continuous at 4? Well, as we can see, f of 4 does not exist, so no. That's it. F of 4 does not exist. Well, here, does f of 4 exist? Yes, f of 4, for number 68, f of 4 does exist. What is the limit as x approaches 4? Well, the limit as x approaches 4 from the right, yeah, we haven't done that one. Sorry, this one you wouldn't know how to find that limit. The limit as x approaches 4 from the right is actually positive infinity, and the limit as x approaches 4 from the left is 16 plus 12 is 28. So infinity does not equal 28. So no, again, this function is not continuous at x equals 4. Or yeah, I guess I didn't need to do the limit. F of 4 does exist here. Oh yeah, I guess I did need to do the limit, my bad. So the limit does not exist at 4, so therefore this function, this piecewise function, is not continuous at x equals 4. Sorry for the pause there. Now I'm going to jump up here to number 73 because it's on my screen. The one-sided limit. So when x is approaching 3 from the right, we still replace x with 3, and we get 0 over 0. So we're just going to go ahead and factor the numerator, and the denominator cancels with that factor in the numerator, and so we just get 3 plus 3, and which is 6. Okay. Find all the numbers at which f is continuous. Well, at which numbers is f discontinuous? For number 74, the tangent of x, which is equal to the sine of x over the cosine of x, and we have to stick that 4 in there. So the function f is continuous as long as the cosine is not equal to 0. Okay. So we're just going to say f is discontinuous at x equals all the values in which the cosine is equal to 0. So that would be pi over 2 plus 3 pi, well, pi over 2, 3 pi over 2, 5 pi over 2, and so forth. So discontinuous at x equals pi over 2 plus pi k for k an integer. Okay, so basically it's multiples of pi over 2, and there's other ways to write that, but that's the easiest way, I think. So it's discontinuous there and therefore continuous everywhere else. Okay. Let's go ahead and replace in number 75. Let's replace x with 2. And so f of 2 is equal to 2 minus 2 is 0. The limit as x approaches 2 of f of x, the limit from the left is 0. Left-hand limit is 0. Right-hand limit is 2 times 2 minus 4 is 0. So the limit is also 0. And so, therefore, f is continuous for all real numbers, and it's not ever discontinuous. So the answer for number 75 is f is continuous on the interval, or I should say continuous over the entire real number. I didn't say that very well. Fading out here. F is continuous for all real numbers. How about that? Number 76. Let's see here. What is f of 4? F of 4 is 8. The limit as x approaches 4. So the three conditions that must be met are the limit has to exist, the function has to exist, and the limit has to equal the value of the function. So the limit does exist. The limit is equal to 8. Limit equals 8. F equals 8. Therefore, continuous on all real numbers again. Continuous on all real numbers. Okay. Number 77, we switch gears here and we're finding the slope of the tangent line to the graph at the given point. So in order for us to find slope, we want to find f prime, because f prime is the slope. So f prime of x is 2x plus 5, and we see two numbers here, and you should know that f prime depends on the x, and so f prime at 4. So f prime at 4 is equal to 2 times 4, which is 8, plus 5 is 13. And that's the slope at that point. 13 is the slope at that point. Any other problems on here? Nope. That's it.